let's get a little insight into our boiling through cooling process here. First of all, we need to talk a little bit about pressure. So gases exert a pressure on surfaces, and a common example would be to blow up a balloon. The more you exhale into the balloon, the higher the pressure as the amount of gas increases, and eventually the pressure gets so high the balloon's going to pop. Air exerts pressure, and we kind of ignore that pressure just because we're used to it. Here is a pressure probe, and we are detecting air pressure as the air molecules enter this, and we can register it on a Bluetooth graph here. So let's push start and see what we got. What do we get? We got absolutely nothing because I missed the button. There we go. And there we go. This is the air pressure in the room here being registered here with our Bluetooth probe. Now let's measure the pressure of the air inside of the sealed container. And this is water with a little bit of food coloring. And let's see what that pressure is. And this is water that's at room temperature. And so let's look at what the data here says. So looks like it's not much different from the air pressure. In fact, it's identical to the air pressure, which is what we'd expect. Take this out. So we're still Now let's see if the pressure on the inside is different with the hot water and food coloring. Notice we have condensation there. So this is hot water. Let's see if we get a air pressure that's different than the pressure that we just checked. Okay, well there we go. So that's the pressure over the surface of this hot liquid. What's happening is the hot liquid, some of that liquid is converting to gas, and that gas has increased the pressure on the inside significantly. So again, the more hot steam on the inside, on the surface of the water, the higher the pressure is on the inside. Well, what happens now when we reheat this up, seal it, get high pressure on the inside, and then plunge it into cold water? Let's see what happens to the pressure. We are boiling vigorously now. This system here is at a high temp, a really high temp. So let's try the demo again. Now we're adding the pressure probe now. And let's start this. Okay, I'm squeezing down hard on this, and we got a high pressure situation on the inside. I'm holding this tightly. Now, let's put it into cold water and see what happens to the pressure. And there we go. Huge decrease in pressure. And let's see, is this showing signs of boiling? It is showing signs of boiling, and let's check the data again. Quite a bit lower. It's almost a 40% decrease, or that's from our starting point there, so it's going from over 40% decrease. And there we are. So we're really low. Relatively speaking, it's down to half pressure here where we started, beginning to level off, and maybe a little bit still signs of boiling. Let's take this out. Now, this is really tight. The cork is really, really tight. And let's check our pressure. It's going back up a little bit. Why? Because this is still hot and we're getting some of that liquid being converted to gas, which is accounting for that increase in pressure. Let's put it back in the cold water. And that steam on the inside condenses into liquid water, and the liquid water doesn't exert any air pressure on the inside because it's liquid and not a gas anymore. This out. Now it's heating back up again. And it's leveling off a little bit. We notice this is really tight on here now.